Okay, now coming to question number 51. A 5 kVA transformer has a turn ratio of N1 by N2 is equal to 10. The impedance of the primary winding is 3 plus J5 ohms, while that of the secondary winding is 0.5 plus, this one will be J8 ohm, not 5. This is a printing mistake. The impedance of the transformer when referred to the primary will be, so here it is asked the impedance of the transformer when referred to the primary. So you should know that when the impedance is referred to the primary, then how to find it. So the formula is Z1 Z primary plus the turn ratio N1 by N2 square into the secondary winding impedance 0.5 plus, this one will be J8 ohm. Okay, so the equation, you will see the equation will look like this one. This one, impedance when referred to primary, Z1 plus N1 by N2 whole square into Z2. That is N1 by N2, it was 10. So 3 plus J5 plus 100 into 0.5 plus J 0.8. You will get the answer as 53.J85, which will be the option C, 53.J85 ohms. This is the right answer. Now, this was in case of the impedance of the transformer when referred to the primary. But if they ask the impedance of the transformer when referred to the secondary, what will be the formula? In that case, the secondary impedance plus N2 by N1's whole square into the primary impedance will be your answer. So the equation will look like Z2 plus N2 by N1 whole square into Z1. Now next question. Directional induction type overcurrent relay is used for protection of directional induction type overcurrent relay is used for protection of ring main distribution line. Option C. Question number 53. The deflecting torque of a moving iron instrument. We know, we have studied earlier that the deflecting torque of moving iron is proportional to I square. So these two options can be confusing, but remember that the deflecting torque of a moving iron instrument is half into I square into dl by d theta. So the correct option is option B. Question number 54. In a PMMC instrument, the torque weight ratio is high. That is, the weight of the moving devices is very less in case of PMMC instrument, and this is the ideal case. The ideal case is that for an instrument the torque weight ratio must be high. Now another question they can give is that which instrument has the lowest torque weight ratio? Then you should give the answer, it is electrodynamometer type instruments which has the lowest torque weight ratio. Question number 55. The advantage of neutral earthing. Why neutral earthing is done? Neutral earthing is done to eliminate arcing ground. Now, there can be a question that what is this arcing ground? This arcing ground takes place when the neutral is not earthed. Okay. Later on, if this topics comes, I will discuss. If you people request me, then I will discuss this arcing ground part very nicely. But uh, uh, in YouTube also, you can search this arcing ground, and there are some videos over this topic arcing ground. You will understand. So, the advantage of neutral earthing is to eliminate arcing ground. Question number 56. Two charges of equal magnitude are separated by some distance. If the charges are increased by 10 square, to get the same force between them, their separation must be. So, here they are taking force into consideration. So we know our formula is there. Force is equal to K into Q1 by Q2 by the distance square. By the distance square. So, if two charges of equal magnitude are increased by 10%, then this one will be 110 into 110 by 100 into 100, which will look like this one. Let me show you question number 56. Okay, this is the equation. Q1 by Q2 is equal to D square. So if we increase these two charges by 10%, so this one will be 110 by 100 into 110 by 100. 110 by 100 for Q1, 110 by 100 for Q2. So this one will be something as 121, 121, 12100 by your 10000. Now, in order to keep the force constant, here it is said to get the same force between them, their separation must be this d square, this d should also be increased by 10%. So therefore, if we are increasing 10% and 10% individually for Q1 and Q2, then in order to make it equal, we need to increase the value of d by 10%, and it is square, therefore the value will be same to keep the force same. So charge increased by 10% to keep the force same, their separation must be increased by 10%. So option B, increased by 10%, is your right answer. Now question number 57. A DC motor is running with a certain load. The effect of adding an external resistance in the shunt field circuit. Okay. Now here it is said that the field circuit is shunt. Therefore, here from here we can conclude that this is a DC shunt machine in which torque is proportional to armature current. But this relation is not required, as they are asking what will happen if an external resistance is added in the shunt field circuit. So if we increase the resistance, then the shunt field current will decrease. Field current will decrease. Obviously, you are increasing the resistance, so the field current will decrease, and therefore the flux will decrease. Now, in case of DC motor, we have a relation that EB back EMF is equal to Pn phi by 60 into Z by A, where P is the number of poles, N is the speed, phi is the flux, and Z is the number of conductors, and A is lap wound or wave wound winding. If it is wave wound winding, then it will have a value of 2, and if it is lap wound winding, then it will have a value of the number of value equal to the number of poles. And there is another thing you should remember. If it is said that the lap wound winding is simplex, then the value of A will be equal to the number of pole. But if it is said that the lap winding is duplex, then the value of A will be 2 into number of poles. Now from there you can see that P, the number of pole, is constant, then your Z, number of conductors, is constant, and your lap winding or wave winding, that is A, that is constant. So now the value of EB back EMF will be proportional to flux and speed phi and N. Now N is directly proportional to EB by F. So if flux is increased, the speed will decrease, and if flux is decreased, the speed will increase. And here we are decreasing the flux by decreasing the current and by increasing the resistance. So ultimately the motor speed will increase to increase the motor speed. Question number 58. While performing short circuit test on transformer, the impressed voltage magnitude is kept constant, but the frequency is increased. Now, in case of short circuit current, it is said that the short circuit voltage Vsc is constant, but the frequency is increased. Frequency means frequency affects the impedance, as impedance is equal to R plus J R plus XL, where XL is equal to J omega L. and omega is equal to 2 pi f. So if the frequency is increased, the denominator value will increase, and thus as the current is inversely proportional to the value of the frequency, the current, short circuit current, will decrease. Let me show you if there is any relation I have written. Yes, this one. ISC is equal to VSC by ZSC. Now ZSC is equal to R plus JXL, which is equal to R plus J omega L, and omega is equal to 2 pi f. So if frequency is increased, the overall denominator value will increase and current will decrease. So the right option here is option B. It will decrease. Question number 59. A choke coil of inductance L and series resistance R is shunted by a capacitor C. The dynamic impedance of the resonant circuit would be. Now this is a very specific circuit, specific parallel resonating circuit. This circuit looks like this one. R is in series with inductor and is in parallel with the capacitor. And the dynamic impedance of this circuit is L by RC. This one you have to remember because this circuit is a configuration of the parallel circuit. Question number 60. This is said that two capacitors each having capacitance C and breakdown voltage V are joined in series. The capacitance and breakdown voltage of the combination will be. Now capacitors are in series, therefore 1 by C plus 1 by C is equal to C by 2 by C, which is equal to C by 2. So C by 2 will be our capacitance because it is in series, and the breakdown voltage of the combination will be 2V because voltages are also connected in series. Breakdown voltages are joined in series. So therefore it will be 2V, C2 by 2V.